So we'll start off today, because I know just in chatting with some folks in here, we'll start off today with a little bit of a review from last week. We'll go through some of the slides. We'll look at the notes. Obviously, if you're watching this, or if you go back and watch this, you can pause at any time you want to and take the notes. So I may not stay paused as long as some of us want in here. I most definitely will when we get to the newer words and the vocabulary words from this week. But we've moved into a new part of weather. We're done with the layers of the atmosphere. We're not talking about clouds every day like we have been as far as notes go. We'll still look at them on our weather journals. We're talking more about wind and weather and how winds are formed. So when we introduce this, and the reason why we have to talk about latitude and longitude is winds are formed on Earth due to the uneven heating of the Earth's surface. Now, where you are in these vertical lines of longitude really doesn't tell me a whole lot about the weather in your area, because I need to know where you are horizontally on these lines. Then I can tell you a whole lot about your weather. The closer I get to the equator, what happens to my weather? Knox. It gets hotter, and the further away, north or south, if I move this way or if I move this way, it starts to get colder, right? That's why it's going to be very important for us to understand latitude, especially the equator, because that divides us into the northern and the southern hemisphere, which experience opposite seasons, which we talked about last week. And so again, latitude will come up a lot. Longitude, not so much. I know you talked about it in media, but we won't really get into that as often as we will latitude. Latitude is extremely important for us as we go through things. This is extremely important. Air temperature. I know we took notes on that last week. We talked about how cold air, if I could trap cold air into a cube and actually see the molecules, Noah, inside that box, I would be able to see more molecules of cold air than I would warm air, because as the molecules lose heat energy, they get closer together. Cold air is a little more dense. That's why cold air sinks and hot air rises, which we've kind of talked about before. This picture is important. We have that on the anchor chart. And we talked about how cold air is more dense. We just took some of this thing because the molecules are closer together, and that causes cold air to sink. Hot air is less dense. The molecules have more heat energy. They're moving further apart with more energy, and therefore it is less dense. That will come into play because that's the start of our convection cells. Humidity. Humidity is an important term. Who remembers the weather tool that we would use to measure humidity? We don't talk about this one often, but it is something that could pop up every now and then. What weather tool measures the humidity, the moisture in the air? It's not on our weather notebook, so it's a little different. If you don't have it, I think the person across from you does. Ava, what do you think? Okay. Hygrometer. Hygrometer. The hygrometer measures humidity. Again, that might show up on a quiz. If I see it when I'm creating the test, I'm going to put it on there so we can talk about it. It'll be on our study guide, because if that's the case, it could show up later. But again, humidity is the amount of moisture in the air. I didn't take notes on humidity. I didn't bother stopping to write that down. Now, updraft and downdraft. Correct me if I'm wrong. I think we had to stop here. Is that correct? All right, so we're going to start our notes in this class here. Updraft and downdraft. When I look at your vocabulary word for this week, this is vocabulary words number 4 and number 5. Now, in no shock at all, updraft is an upward movement of air and downdraft is a downward movement of air. Oh, I know. You only have to remember the temperature of the air that goes up and the temperature of the air that goes down. And you already know this. We've said 100 times that hot air rises and cold air sinks. We did an experiment where hot water was rising and cold water was sinking. Remember the convection cell we saw in those mason jars? We already know all of this. So if we're going to take notes on this portion, it is going to be right here. Updraft and downdraft. Can you see that at the bottom of the notes on my page? Right here. Here and here. Okay, I'm going to pause the video. So again, as we were talking, we know that because there is an upward draft of warm air here, it causes a low pressure. And because the cold air is pushing down over here and it causes a high pressure, air moves from high pressure to low pressure, and that's the direction your wind is going to move in. When we get into the sea breezes and land breezes, this should look very familiar. We've already talked about that convection cell and convection current before, but it was kind of unofficial back then with conduction, convection, and radiation. It'll be official probably tomorrow, if not maybe later on this week. All right, wind. I think wind was where I started with my other class today. Wind is a horizontal movement of air because air moves from high pressure to low pressure. As I open up our notes, and I try to get in there because this thing loves me so much. Can you see wind right here? Can you guys see that? Wind is a horizontal movement of air. Now, Cameron, air moves from high pressure to low pressure. You know this because if I blow up a balloon to its fullest extent and I let go of the end of it, no one in here expects air to go inside the balloon, right? Because the pressure inside the balloon is great. The air blows out the other side of the balloon. That's just the way it works. If the balloon is not blown up and we start to blow it up, we're not shocked when air goes in the balloon either, because air moves from high pressure to low pressure. I would kind of maybe underline this last part, put a star beside it or something. The differences in pressure are caused by the unequal heating of the Earth's surface. So in essence, Sky, wind is caused by the uneven heating of the Earth's surface. Wind is caused by the uneven heating of the Earth's surface. And that's right there. I'll pause that. All right, how are winds formed? Again, it all starts with radiation. As I look ahead at next year and they're trying to get rid of conduction, convection, and radiation, I don't understand how we can do that when radiation plays such a key role in transpiration and condensation and how the sun and the uneven heating of the earth through radiation are how winds are formed. I'm really kind of questioning how we're going to do that without still bringing up all of those words. Due to the uneven heating of the Earth's surface, we're going to have winds. Now, my question to you is, how do I know that the Earth is not heated evenly? Think about the Earth, and how do I know it's not heated evenly? Evan. So that is definitely part of it. The way the Earth is, it's night at one side and it's daytime at the other. What's another way I know that not all of the Earth is heated evenly? And you can start thinking about latitude. It'll probably give you the answer. Scott. That's what he was saying, one daytime on one side, nighttime on the other. That's correct. What about how the sun hits the equator versus how the sun hits the poles? Is it the same temperature at the North Pole as it is on the equator? No, because the sun, the way the Earth is tilted, the sun hits those places, it glances off of them, right? And so it's not as hot because it's hot all the time at the equator. The sun heats the Earth unevenly, and that's how winds are formed. We've already taken notes on that, so I'm going to go ahead and go past this stage. Global wind patterns. So tomorrow we're going to do something that I really enjoy, unless I find out she's going to take more people out, although I may still have to do it and they'll just have to make it up. We're going to do something from Discovery Education called Make It Concrete. For those of us at home and that aren't in here, I can't really show you that. I'll show you guys in here what's going to happen. We're going to talk about the polar easterlies, the prevailing westerlies, which we've heard a lot about, right? We're going to talk about the doldrums and the trade winds. And we're going to watch a young lady set sail from France, go all the way down here around the poles and then back up. France is over this way, back over to France by herself on a sailboat. It's an amazing story, unbelievable person. Definitely one of the people I would put in my hero categories because she is amazing with what she's done with her fame and success, even though most of us have never heard of her. But I'm going to show you what we're going to do with the Discovery Education thing before I start giving you the notes as we move on. All right. Out of our global winds, the first global winds that we're going to start with, I think I started at the equator and moved my way out. I did. The doldrums. The doldrums. The doldrums is an area of very calm weather. Now, Knox, if I'm on a sailboat and I'm at the doldrums where the wind is barely blowing and most of it's going up as hot air, I'm kind of having a hard time moving my sailboat around the ocean, right? Also, when you watch the video, it is amazing. Like, we've seen the ocean. The ocean is usually pretty wavy, right? It looks like a flat lake when she's at the ocean. And you'll hear her talking about being at the doldrums and the equator. It's really kind of flat and peaceful. There's a tiny breeze that she's able to capture and kind of keep on moving, but it's a very rough spot. Let's take a look at our notes for the doldrums. They are right here. The doldrums happens near the equator, mostly hot air rising. Very little wind and the ocean is calm. As we move a little bit further away from the equator and the doldrums, we move into something called the trade winds. Now, the trade winds are winds that blow from the east to the west. They blow towards the equator. Lots of Europeans back in the day would use the trade winds, Knox, to leave England and move their way to the east to North America, South America, and other places where they could trade with other people. And then they would probably catch the prevailing westerlies on their way back, unless they decide to go a super long way and all the way around. But I doubt very seriously they did that. So trade winds, as we look at the notes, is right here. Winds that blow in a curved western direction towards the equator. Trade winds. All right, as we continue to move further away, we have the doldrums at the equator. We have the trade winds here. We are now moving into, Noah, the most important of the global winds, because these are the ones that affect our weather the most. I put a star beside these in my notes. You should probably do the same. The prevailing westerlies. We heard that today as we were looking at the weather map, and the guy from WXI was looking at stuff in California and predicting that by Friday it would be here. He knows this because the prevailing westerlies move weather across the United States from the west to the east. You can see the United States right there. You can see the prevailing westerlies curving and moving the weather across the United States. Extremely, extremely important. Yes, ma'am. Okay. What? The weather. The weather the guy on the news talked to us about today when we watched it in class. And we paused and said, how does he know that that's going to make it here? Were you in class at that time? You had to be in class at that time. Okay, we talked about it in class today. Prevailing westerlies, I have a star beside it. They move in a west to east direction. They are responsible for moving weather from the west coast, like out at California, over to us and other places on the east coast. All right, have a minute left on the video, so we're going to move on from the prevailing westerlies to the polar easterlies. Not a shock. These are winds that blow near and around the poles. And I know it says easterly, so you're going to think that they blow to the east. That is not correct. They begin in the east. They blow from east to west. They blow from east to west. Polar easterlies are right here. Winds that blow east to west near the poles. I'll pause and let you get that one on there. All right, so for those of us that were not in class, if you missed some of this, you can go back and watch the video, the beginning of it. It's got all of the vocabulary words on there that you might need from last week and all the way to this week. You can go back and look at all those words and get all the definitions in that you need. And we'll post this for today. Yes? You got to wait. You're like fourth in line. Jonathan says...